Quadratic functions and models. Quadratic function of the variable x is a function that can be written of the form ax squared plus bx plus c, where a, b, and c are fixed numbers and a is non-zero. For example, f of x equals 5x squared minus x plus 5. Here a is 5, b is -1, and c is 5. Using function notation, we can evaluate f at various values. For example, f of 0 is the value of f when 0 replaces all of the x's. In this case, 5 times 0 squared minus 0 plus 5 is equal to 5. Similarly, with non-numerical values, we can evaluate an expression like f of a, where all the x's are replaced by a's. In an expression like f of a plus h, all the x's are replaced by a plus h's. Here we get 5 a plus h squared minus a plus h plus 5. When we distribute the negative sign onto the a plus h and we square the a plus h, we get something that looks like 5a squared plus 2ah plus h squared minus a minus h plus 5. Or collecting like terms, we end up with 5a squared plus 10ah plus 5h squared minus a minus h plus 5. Every quadratic function of the form f of x equals ax squared plus bx plus c actually forms a parabola. The vertex is the highest or lowest point of the parabola. The x-coordinate of the vertex is -b over 2a. The y-coordinate of the vertex is f of -b over 2a. If a is greater than 0, then the parabola opens upward, and we call the parabola concave up. If a is less than 0, it opens downward, and we call the parabola concave down. There's a lot of symmetry involved with parabolas. The parabola is symmetric with respect to the vertical line through the vertex, which is the line x equals -b over 2a. X-intercepts occur when f of x equals 0. That is, when ax squared plus bx plus c equals 0. Solving this equation for x, either by factoring or using the quadratic formula, will give you the x values. So the x-intercepts are x equals -b plus or minus root b squared minus 4ac over 2a. The y-intercept, on the other hand, occurs when x is equal to 0. So we can evaluate f of 0 and find that y is equal to c. Here's an example. The demand equation for a product is Q equals -2,000p plus 150,000, where Q is the annual quantity sold at a price of p dollars. What price should be charged to obtain the maximum annual revenue? First, we have to figure out what the total revenue is. Total revenue is price times quantity. So we can find the revenue equation. So R equals P times Q. We know what Q is, so that's P times -2,000p plus 150,000, or -2,000p squared plus 150,000p. Notice that the number in front of the p squared is negative, which means that the parabola is concave down. So there is a maximum possible total revenue. So if we look at the equation, we know the p-coordinate of the vertex is -b over 2a, b is 150,000, and a is -2,000. So our p should be 150,000 over 4,000, or 37.5. This value of P gives the highest point on the graph and thus gives the largest value for the total revenue. That maximum revenue, when we plug in P equals 37.5, is $2,812,500.